Okay, let's take a quick look at the rock cycle. Here's a diagram showing the rock cycle in the Earth's crust. This particular diagram can be found in the New York State Earth Science reference tables. What it shows are the different types of rocks and how they can change over time. Let's go through a quick example. Here is a chunk of an igneous rock known as granite. You can see it's made up of intergrown crystals of potassium feldspar and quartz and biotite, and that's what gives it its speckled look. Now, as we mentioned, granite's an igneous rock, which forms from the solidification of melted material, magma or lava. Granite happens to form deep underground from the slow cooling of magma. But the question we want to look at now is, well, what can happen to this igneous rock over time? And there's a handful of possibilities. The first thing that could happen is our granite could be lifted up, forced up from beneath the ground, where it's exposed to weathering and erosion. The wind, the rain, the ice, these forces break this rock down into little small pieces called sediments. So now our granite has been broken into small pieces of granite. Now these little small sediments can be deposited and buried and then compacted and cemented together to form a brand new rock called a sedimentary rock, like this piece of sandstone. So simply by weathering and eroding the granite into sediments and then squeezing the sediments back together, you've converted your igneous rock into a sedimentary rock. But that's not the only thing that can happen to our igneous rock. What if it is pushed even deeper underground by the movement of Earth's tectonic plates, and in so it is exposed to intense heat and or pressure, causing it to metamorphose or recrystallize into a metamorphic rock, like this piece of gneiss seen here. So, with the simple addition of some heat and pressure, we've turned our igneous rock into a metamorphic rock. But there's still one more option. What if our igneous rock is exposed to intense heat, causing it to melt and return into liquid state of magma? Well, it can then, of course, cool and solidify again, giving us another igneous rock. But maybe this time it will cool quickly and give us something with smaller crystals or maybe no crystals at all, like this piece of obsidian. So what you can see is that on the rock cycle, any rock is able to turn into any other rock when exposed to the different processes in and on the Earth's surface. Remember, we start with these three types of rocks. These are our three classifications. And from them, we can go to anything else. Again, let's look at the igneous rock, right? Igneous rock, we know, forms from melting into magma and solidification. But remember, it can melt again, and that process can happen over and over and over again. So I can have an igneous rock that becomes igneous again, maybe a different kind of igneous rock. But any rock can melt into magma and form an igneous rock, as seen on the chart. Sedimentary, metamorphic rocks, they can all be melted and ultimately result in an igneous rock forming. Well, let's look at the sedimentary rock. Now remember, these form from sediments that have been deposited and buried and pressure causing them to compact and cement together. But of course, any rock can be weathered into sediments, and therefore any metamorphic or igneous rock can become a sedimentary rock. Finally, we have our metamorphic rock, and remember, these form when rocks are exposed to intense heat and pressure. But of course, that process can take place with any type of rock, sedimentary, igneous, or even metamorphic rocks. So the key idea behind the rock cycle is the fact that any rock can become any other kind of rock. It can even become itself. Change is always taking place. It's generally slow over many millions of years. However, the results can be impressive. Thanks.